Find the pair of walls that, if filled between with water, would result in the maximum volume of water. Hi everyone, we're here today for another Exponent mock interview with Tiantao. For those of you who aren't already familiar with Exponent, Exponent helps you get your dream tech career with our online courses, expert coaching, peer-to-peer mock interviewing platform, and interview question database. Check it out at tryexponent.com. All right, thanks so much for being here with us today, Tiantao. It's so great to have you. Would you quickly introduce yourself for our viewers?
Hi, everyone. My name is Tiantao Lu, and I'm currently a software engineer at Waymo, which is a child company of Alphabet. I'm working on perception team, working on distributed system optimizations.
Awesome. That sounds like such cool work. So let's get right into it. Our question today is, given a series of n coordinate pairs that represent the top edge of vertical walls rising perpendicularly from the x-axis, find the pair of walls that, if filled between with water, would result in the maximum volume of water.
I want to quickly draw some pictures.
Sure.
So let's draw a figure, like the x-axis is the indexes and the y-axis is the height of the container. Mm-hmm. So a simple example would be, all the integers are exactly the same. This all one. And then in this very simple example, the size of the maximum container will just be 4 times 1, which is 4, which is just be this container.
Right.
And then my second example here will be, what if the integer array is like continuously increasing? For example, here, 1, 2, 3, 4. And then in this case, I think my maximum size of the container is shown here, is again 4 times 1 equals to 4. Does that sounds reasonable to you?
So can you tell me why the maximum volume would be the 4 rather than, for example, you could have the container go from like the second to the fourth one instead. So that would be like 2 times 3, I think, which is 6.
Yes, I think you're right. So in this example, if we go here, so the actual maximum number will be 2 times 3 equal to 6. Mm-hmm. So I think like this example shows maybe like if we go greedy, then obviously the size of the container is the width times the height. And then in order to maximize this product, then if we go greedy, then we probably want to select the largest width and larger the height. But here we have a trade-off here. If we selected the largest width, then we end up with this solution. However, this is suboptimal. As we can see, we can actually have reached a much better solution here. So I guess like the takeaway here is, we can probably start with some good solution and to see whether we can improve it. And then like let's take like this example again. What if we select the first solution as with the maximum width, and then let's see how we can improve it. So here the width is 4, the height is 1, which is the minimum number of the minimum number of the 2 integers at the side. So this one is actually the minimum number of this array 0 and array. So if we want to improve the size of this container, we want to say, hey, how can we make the container size bigger than what we already have? So this, we can say this already have the maximum width. So any container, for example, our optimal container here has less weight than this initial solution. Then if we are going to beat this initial solution, the height of our container in consideration must be higher than the original one, which has the height of 1.
Right, and that's
So-
assuming that we're strictly narrowing the width, right?
Exactly. So here, if we are making the window narrow, we have two choices. We can either shift the left pointer right or the right pointer left. So which choice are we making? So here we can see our optimal solution is going to shift this 0, I highlight here, to the right. Why are we doing that? Because like the height of array 0 is actually the minimum of the two. We can safely say if we are going to discard our higher integer here, any solution will be suboptimal than the initial solution. So we can safely remove all the candidates there.
That means that we strictly want to move the barrier, the wall that's
here.
Yeah, the one that's shorter, right? Yeah.
Yes. So that's I think that's you know some insight when we can do the optimization. Yeah. So I guess like this problem, if we are going to solve it by brute force approach, then obviously we can exhaust all the container candidates by doing a double loop, like fix the left pointer, fix the right pointer, and then exhaust all the solutions and pick the best one. So that approach will obviously take O n squared time, but I think by following our discussion and analysis before, if we start greedily by selecting the 2 pointers at both boundaries, and then we can shift the window inside, then there are chances we can improve this algorithm. Does that make sense to you?
Yes, completely.
I should like ask some clarification questions, maybe, you know, so because like we are doing this product, then I have to make sure, you know, that the result of this product fall into maybe the integer value.
Yes, it always will be an integer.
And then like we cannot, when we are using this formula, I kind of make the assumption that we cannot like tilt or slant the container. Is that a valid assumption I can make?
Yeah, the container should always stay horizontal.
Yeah. So yeah, that is good. So yeah, I feel like I can basically use a 2-pointer approach and then solve the problem. If that sounds reasonable to you, I'm going to go and code it up. I'm going to name this function. And I can assume like the input maybe is a vector of integers.
Yes, you can. And those integers represent the heights of each of the walls.
Okay.
In order.
And then I'm going to use the 2-pointer approach we discussed before. So I'm going to say, hey, I have a size of the array. This is my left pointer. Then this is my right pointer. I should have some initial solution. Let's say. So another clarification question I want to ask, like, can we assume, for example, the size of this vector is a legitimate number? What if they only have one integer?
You can assume that it'll be at least 2 integers.
I'm going to calculate the area of the current container, which is basically the width times the height. The height will be determined by the minimum of the both side. And now,
Okay, so this update basically just finds like the new maximum
the new maximum one.
volume that you've seen, right?
Yes.
Yeah.
And then I need to fill up this while loop condition, and also I want to determine whether or what strategy I should move the 2 pointers. So let's fill up here. So here the strategy is always like move the pointer with smaller height. That means the left pointer is smaller, then we are going to move the left pointer to the right. Otherwise, we are going to move the right pointer to the left.
Right, and that's because we always move the wall that's currently shorter, right?
Yes, that's correct. And then I want to double check what if like the height of the left and of the right is equal. I think in that case, we can move either pointer, that will be fine. Because that one is not going to beat our current solution because the width is shorter.
Yeah.
So yeah, I can either use a smaller or less or equal to sign.
Great.
So here I need to satisfy this condition. So what if like I and j are equal? Then we are left with only one height, which doesn't make any valid container. So I think like once I and j is equal, we should just jump out of the loop.
Yeah, that makes sense.
Yeah. So yeah, so this looks good to me, and just want to quickly go through our example here. For example, 1, 2, 3, 4. And then the initial solution, initial I will point to 1, initial j will point to 4. Let me write here, j. And this one give us the solution of area equals to 4. And then because the 1 is the height of 1 is the smaller one among the two, so we move this pointer to the right. So I is here, j is here. So this one give us the area of 6. And then the next iteration, I is here, j is here. So this one actually also give us the height of 6.
That last one,
here,
the width is 1, right?
that's correct. And then this one is where we break the loop.
Because I and j have met each other at that point.
Yes, so that makes sense to me. So I'm gonna test my code here. And this one gives me 4, which is incorrect.
Yeah, we're expecting 6, right?
We are expecting 6 here. So what could be wrong here? Yeah, I think the formula here should be the width I left with a +1 sign here, right? So here.
So on line 5, I didn't realize before the width there is actually 2, right, rather than 3.
Yeah, actually, yeah, I should ask this question earlier. Like, how do we define the width? The width is like the difference between the pointer index or the difference between the pointing +1.
You can assume that the walls are like basically infinitesimally thin, so then the width would just be equal to the difference in indexes.
Yeah, that makes sense. So here is actually 3. This guy is 4.
Yeah, perfect. So in this case, then your code did return the correct answer.
Yes. And then let's test the second one.
So what are we expecting for this example?
So for this example, we are expecting the height will obviously be 1. And then the width will just be 3 according to our definition. So I expected the program to output 3 in this case.
Okay, great.
Which is the case. And then lastly, the last example here, I think these two gives an answer of 1. And if we go greedy, we can achieve maximum area of 2. So I'm expecting an answer of 2 in this case.
Great.
Which is correct. Yeah, so I'm happy with my implementation.
Okay, any other test cases that you would want to test?
Yeah, maybe I should probably ask this early, like what if the height are, for example, negative values, and I think in that case I should probably make that area to be 0. So in that case, I should probably have some protection here.
Well, you can assume that all of the integers we give you will be non-negative, but they can be 0.
Yeah. So maybe I want to test the case where the height is 0.
Sure. Yeah.
And then yeah. So these are the test cases I can think of. Like, feel free to comment if you suggest anything else.
Yeah, that makes sense. I'd love to see that example.
So in this case, the optimal solution will still be 2 in this case, because we cannot include this 0 value here.
Yeah, and there are multiple containers that correspond to a volume of 2, right?
Yeah, either we can choose this one or we can choose this one also.
Great. And then one last follow-up question is, what is the runtime and space-time complexity of this code?
Yeah, good question. So I think because we started from the 2 boundaries, and then we are moving this I and j inwards toward each other. So we are basically only touching the each element by once. So I think the overall time complexity in this case will be improved to ON, where n is the size of the array.
Yep.
And then the space complexity, we are only using constant variables here. We're not using any extra variables, so the space complexity will just be O1.
Okay, perfect. I think this is a great place for us to pause then and analyze this interview a little bit. So Tiantao, great job. What did you think went well about this interview, and what do you think you would want to improve more?
Yeah, I think the biggest the trouble I have is when after run this example, actually the answer doesn't actually match with my expectations. So I would just say when we are coding, if I have a second chance when I was coding this formula for the max area, I want to double check with my interviewers, whether this formula is correct or not. So when I was initially doing this example on line 3, I was thinking maybe the width of the container should be 4, but the real expectation, the size of this container should be 3 instead. And also, I think my second feedback is maybe some of the clarification questions I should probably ask earlier then later. So I feel like I asked some clarification questions while I was doing the coding. So I got lucky this time. I mean, there's nothing, unexpected from interviewers, but you never know.
Okay, perfect. Yeah, I agree with a lot of that. I thought you actually did a really fantastic job, first of all, of coming up with insights that guided you to improve the brute force solution into this greedy approach. So, for example, I really like that you mentioned that if you start out with using the furthest possible walls, then in order to improve the volume of water that you can contain, you have to first select the wall that is the shortest currently, and then move that inwards because your width can only narrow from that point. Yeah, so I think that was a really smart insight. I also like that you, as you were coding, you explained what each individual line of code did, so that really helped me follow along, and it was in general like very clean code that was easy to read. And I also thought that your analysis of the runtime was very well explained as well. As for things that could have made this interview even better, I agree, like asking all of the clarifying questions in the beginning often helps, especially with, I also messed up like this initially too, of like getting the right answer for this test case and verifying that we, in the examples that we try in the beginning, that those answers are correct before trying to match them to our code. And then the one other thing is that I think when you're trying to explain your approach in the beginning with the greedy approach, it helps to still explain what greedy approach actually means, so that you're starting with 2 pointers, for example, right? So I was already familiar sort of with what that consisted of, but I think it'll be a lot more clear for your interviewer if you're able to explain from very basic terms that you're starting out with 2 pointers, and this is what they represent, and this is why we're moving them inwards, etc.
Yeah, absolutely.
Yeah, so what did you think of all of this? How does that sound?
Yeah, absolutely. You are making very valid points here, and there are certainly room for improvement for me to further sharpening my interview skills.
Yeah, but overall, fantastic job. Thanks so much for joining us today, Tiantao, and thanks everyone for watching. Good luck on your upcoming interviews. Bye, everyone.
Thanks so much for watching. Don't forget to hit the like and subscribe buttons below to let us know that this video was valuable for you. And of course, check out hundreds more videos just like this at tryexponent.com. Thanks for watching, and good luck on your upcoming interview.